A very good morning to all. Our respected Dean Faculty of Science, Professor K. Krishna Reddy Garu, Professor Y. Nazir Ahmad, Head of the Department Physics, and DOS Chairman Dr. Y.P. Venkat Subbaiah sir, and external expert member Dr. N.V. Prasad, Usman University Physics Department, and other faculty members, students, and research scholars, and all. A very good morning to all. Today here the PhD student Madala Gurulakshmi is going to defending her PhD Viva was presentation. With the kind permission of Dean, DOS, and Head external members, can I, sir? Can I start, sir? N.V. Prasad, sir.
Very good morning, all of you. Okay, we can start now. With help of viewers and other things.
Thank you, sir.
Good morning to one and all. This is Gurulakshmi. Sir, share out. Ikkada telustu. Sir, is it audible, sir? Is it visible, sir?
Hi, you are audible, Amma. Can start.
Yes, sir. Is it visible, sir? My presentation.
No, visible is not visible. You share the PPT.
May I start, sir?
You can.
Yes, thank you. This is Gurulakshmi, sir, research scholar under the supervision of Dr. M. Raghavendra, Associate Professor, Department of Physics, Yoga Vemana University. Now I am going to present my PhD final Viva presentation titled as Development of Platinum-Free, Cost-Effective and Efficient Counter Electrodes for High Performance Dye-Sensitized Solar Cells. This is outline of my presentation. Introduction, followed by experimental section, and followed by results and analysis of the work done, and followed by conclusion. This is organization of my PhD research work planned as development of efficient electrodes for dye-sensitized solar cells, and objectives are synthesis of low-cost counter-electrode materials, development of counter-electrodes and its characterization, fabrication and performance evaluation of dye-sensitized solar cells. This is the work division of my PhD research work. And these are the publications which I have published from this research work. So actually, energy sources are categorized as two types: renewable energy sources.
Gurulakshmi, meedi PPT kanipetadamma.
Yes, sir.
PPT chupichanడి. Yeah.
Sir, is it visible, sir? My PPT.
Visible. Visible. Then you can go on.
Is it okay, sir?
Okay, Amma. Can start.
Oh, yes. May I start from first onwards, sir?
Can start here only. Why go?
There are two categories of energy sources available: renewable energy sources and non-renewable energy sources. Non-renewable energy sources are fossil fuels. These are like coal, natural gas, biomass, oil, etc. But with the increasing demand of energy, the consumption of fossil fuels is also increasing day by day. Hence, need to consider other sources of energy, which is renewable. Among these renewable energy sources, solar energy is the clean and abundantly available for free of cost. Hence, solar cell is the promising alternative for renewable energy sources. What is meant by solar cell? A solar cell is an electrical device which converts light energy into electricity. This is the statistical review of energy consumption in world. And this is the statistical review of energy consumption in India. Importance of the present work. Actually, solar cells are categorized as three generations. These are first generation solar cells, exhibited efficiency up to 20%. These are the cost of energy production per watt is high. And these are second generation solar cells. These are also expensive. So third generation solar cells are developed. These are cheaper compared to first and second generation solar cells. These have an advantages like transparent, flexible, colorful, low cost of fabrication, better performance in diffuse light, less dependence of performance on angle of light incidence, lower energy consumption during manufacture. But here platinum is used as a standard catalyst for radiate reduction. It is an rare earth material and also expensive. So in the present work, we are replacing cost-effective materials with platinum with cost-effective materials. The light energy converted to the electrical energy by the solar cell is similar to the photosynthesis process of plants. Disensitive solar cells mainly consist of three components: photoelectrode, counterelectrode, and electrolyte. This is the working principle of disensitized solar cell. Photoelectrode mainly consists of TiO2 nanoparticles of 10 to 12 microns and a monolayer of sensitizer called dye. When light is illuminated on the dye molecules, the electrons in the dye molecules are excited from HOMO to LUMO by leaving the dye in oxidized state, followed by injection of electrons into the conduction band of TiO2. These free electrons in the conduction band of TiO2 will diffuse to the external circuit and reaches to the counterelectrode by delivering work done as an electrical energy. The oxidized dye is regenerated by accepting electrons from I minus in an electrolyte and then oxidized to I3 minus. These triiodide ions will reduce at counterelectrode. This is the cross-sectional view of disensitized solar cell. And what is meant by supercapacitor? A supercapacitor is a type of capacitor which can store a very large amount of energy. These are the various instruments used for fabrication, synthesis, and characterization purposes. For synthesis purpose, used hot plate with magnetic shearer, and for fabrication purpose, used spin coater, spray gun, furnace, hot plate with magnetic shearer, and vacuum system. For characterization purpose, used solar simulator and source meter, and impedance analyzer. This is the fabrication procedure of dye-sensitized solar cell. Taken, cleaned, FTO coated conducting glass plate. On this coated TiO2 paste by using screen print method. These are the TiO2 coated FTO plates. These are dipped in dye solution. These are the TiO2 coated FTO plates. After absorption of dye, these can act as working electrodes or photoelectrodes. And taken another FTO coated conducting glass plate on this coated required material. These can called as counterelectrode. Both these photoelectrode and counterelectrode assembled together and filled an electrolyte. This is the final DSSC device. And this is the fabrication procedure of supercapacitor. Taken to FTO coated conducting glass plates on this coated required material by using screen print or spray coat method. Coated the same material, so these two are similar electrodes. One can act as front electrode and the other can act as back electrode. Both this front electrode and back electrode assembled together by using this filter paper which is soaked in an electrolyte. This can act as spacer, and this is the final device of supercapacitor. The efficiency, the overall power conversion efficiency from the solar cell is calculated by using this formula eta equal to the maximum output from the solar cell to the ratio of input power. Here FF is fill factor and VOC is open circuit voltage and JSC is short circuit current density. Next, results and analysis. First objective is platinum-free nano-additive counterelectrode for DSSC applications. Here, graphene oxide was synthesized by using modified Hammer's method by taking expandable graphite flakes as starting materials. And this synthesized GO was dispersed in DI water and subjected to solar simulator light to induce chemical-free reduction. This exfoliated GO is named as solar simulator reduced graphene oxide. For synthesized GO and SSR GO, we have carried out the X-ray diffraction measurements. In XRD measurements of SSR GO, we have observed an additional peak. It is confirmed that graphene oxide was reduced. And Raman spectra measurements are carried out for synthesized GO, SSR GO, and SWCNH. And observed a two intensity peaks named as D and G band. By calculating the ratios of D and G band, it is confirmed that graphene oxide was reduced. And cyclic voltammetry measurements are carried out to investigate the redox kinetics of I minus I3 minus at counterelectrode electrolyte interface in acetonitrile solvent based solution by taking 3 electrode setup. Here AgAg plus as reference electrode and platinum wire as counterelectrode And GO, SSR, GO, SWCNH, SWCNH, SSR, GO electrodes as working electrode. And higher degree of reduction indicates better catalytic activity, and lower degree of reduction indicates sluggish catalytic activity. In the case of SWCNH, SSRGO, we have observed better reduction, indicates that it has good catalytic activity. And TOEFL polarization measurements are carried out for the symmetrical dummy cells made with GO, SSRGO, SWCNH, and SSRGO, SWCNH. Symmetrical dummy cells means taken two similar electrodes sandwiched together and filled an electrolyte. Here, in the case of SSRGO, SWCNH, we have observed a larger slope, which is indicative that good catalytic activity, and calculated the higher exchange current density values. And electrochemical impedance spectroscopy measurements are used to investigate, to know the interfacial charge transfer process that occurred in DSSC. And EAA studies are carried out for the symmetrical dummy cells made with GO, SSRGO, SWCNH, and SWCNH, SSRGO based electrodes. And here low uncalculated RS and RCT values. Lower RS and RCT values plays the vital performance to decide the performance, plays a vital role to decide the performance of DSSC. In the case of SWCNH, SSRGO, it is observed that it has good catalytic activity. And board phase loss data is taken from EIS data. From board phase loss data, we have calculated the lifetime of charge carriers. Photocurrent density voltage measurements are carried out for the GO, SSRGO, SWCNH, SSRGO counter electrode based DSSCs, and the photovoltaic parameters are tabulated in this table. The SWCNH, SSRGO counter electrode based DSSC exhibited efficiency of 8.27%, which is comparable with the platinum counter electrode based DSSC. Based on this highest efficiency, we have fabricated a dye-sensitized solar cell module. Taken FTO coated conducting glass plate, on this coated TiO2 the structure of drop-in. And this is the TiO2 coated FTO plate after absorption of dye. This can act as photoelectrode. And taken another FTO coated conducting glass plate on this spray coated SWCNH and SSRGO. This can act as counter electrode. Both this photoelectrode and counter electrode are assembled together by using this polymer Meltonics film. And this is the final dye sensitized solar module. And we have operated a tiny electric motor by using this dye sensitized solar cell module under indoor and outdoor light conditions. Video. This is the operation of tiny electric motor under indoor light conditions by using fabricated dye sensitized solar cell module. This is the operation of tiny electric motor under outdoor light conditions. Further, we have integrated the silicon solar cell with the fabricated dye sensitized solar cell module to obtain higher VOC values. These results are published in Solar Energy Journal. Next, second objective is electrodeposited MOH2 flexible counter electrodes for dye sensitized solar cell application. Here, MOH2 films are obtained through electrodeposition method by taking ammonium thiomolybdate and KCl as starting materials under the conditions of -1 volt for 300 seconds in 3 electrode setup. Ag plus as reference electrode, platinum wire as counter electrode, and flexible sheet as working electrode. And for the electrodeposited MOH2 films, we have carried out X-ray diffraction measurements, and from XRD studies, it is confirmed that electrodeposited MOH2 film has hexagonal crystalline phase. And further, we have carried out scanning electron microscopy measurements, and this is the SEM image of electrodeposited MOH2 film, and this is the cross-sectional image of electrodeposited MOH2 film, which is showing sheet-like structure. And to know the surface morphology, we have carried out atomic force microscopy measurements. And A is the AFM image of TiO2 coated electrode over FTO substrate, which is showing needle-like structure. And B is the AFM image of TiO2 with N719 dye electrode, which is showing cluster-like structure. And C is the AFM image of TiO2 with N719 dye, and also ionic conducting liquid coated electrode, which is showing granular-like structure. Here, ionic liquid is used for surface modification of photoelectrode. Transmittance measurements are carried out for the electrodeposited MOH2 flexible count electrodes. Transmittance is the fraction of incident light having specified wavelength passes through the sample or coming out of the sample. Here, nearly 55 to 90% of transmittance is observed for electrodeposited MOH2 film. These are the photographic images of semi-transparent, which is flexible count electrode, and C is the flexible photoelectrode. Cyclic voltammetry measurements are also carried out for MOH2 electrodeposited film, and for comparison purpose carried out platinum film. And from CV studies, it is confirmed that MOH2 has catalytic activity. And from TOEFL and EIS measurements are carried out for the symmetrical dummy cells. And from TOEFL and EIS also, it is confirmed that electrodeposited MOH2 film has good catalytic activity. And board phase flux data is taken from EIS and calculated the lifetime of charge carriers. And photocurrent density voltage measurements are carried out for the MOH2 platinum counterelectrode based DSSC. Here photoelectrodes are taken as surface modified and without surface modified. So the surface modified photoelectrode and electrodeposited MOH2 counterelectrode based DSSC exhibited 4.84%. Based on this efficiency, we have fabricated flexible dye-sensitized solar module. And A is the photographic image of flexible photoelectrode, and B is the photographic image of electrodeposited MOH2 flexible count electrode, and D is the flexible dye-sensitized solar module, and exhibited efficiency of 4.21%. These results are published in Solar Energy Journal. Next, third objective is MOH2 SWCNH bilayer counterelectrode for dye-sensitized solar cell applications. And for electrodeposited MOH2 film, we have spray coated SWCNH and carried out XRD study. From this XRD measurements, it is confirmed that MOH2 has crystalline structure. And scanning electron microscopy characterizations are also carried out. A is the semi-image of electrodeposited MOH2 film, which is showing flower-like structure and spread throughout the FTO surface. And B is the spray coated SWCNH over FTO substrate. And C is the spray coated SWCNH over electrodeposited MOH2 film, which is showing interconnecting in nature. And D is the cross-sectional semi-image of SWCNH MOH2 over FTO substrate, which are clearly distinguishable. And cyclic voltammetry measurements are carried out for MOH2 SWCNH, MOH2 SWCNH counterelectrode. And from this CV studies, it is confirmed that MOH2 SWCNH has good catalytic activity. And from EIS data also, it is confirmed that MOH2 SWCNH bilayer electrode has better catalytic activity by considering RS and RCT values. From TOEFL polarization measurements, it is also confirmed that MOH2 SWCNH has good catalytic activity, and from this we have calculated the higher exchange current density values. And from board phase flux data, we have calculated the lifetime of charge carriers. Photocurrent density voltage measurements are carried out for MOH2 SWCNH, MOH2 SWCNH counterelectrode based DSSC, and the photovoltaic parameters are tabulated in this table. The MOH2 SWCNH bilayer counterelectrode exhibited efficiency of 9.48%. This exhibited highest efficiency. These results are published in Chem journal. Next objective is nano-additive SWCNH assisted carbon counterelectrode for dye-sensitized solar cell applications as well as photocapacitor applications. Here carbon is coated by using screen print method, and SWCNH is coated by using spray coat method. And from XRD analysis, it is confirmed that carbon has good crystalline structure. A is the semi-image of screen printed carbon, which is showing thin, smooth and flake-like structure. And C is the spray coated SWCNH over FTO substrate. And B is the SEM image of spray coated SWCNH over screen printed carbon, which is showing interconnecting in nature. And D is the cross sectional SEM image of SWCNH carbon counter electrode. Cyclic voltammetry measurements are carried out for carbon SWCNH based electrode. And from these CV studies, it is confirmed that SWCNH carbon has higher degree of reduction, which indicates better catalytic activity. And from EIS studies, we have calculated RS and RCT values. Lower RS and RCT values favors DSSC performance. And from SWCN, in the case of SWCNH carbon, it is observed that it has good catalytic activity. TOEFL polarization measurements also, it is confirmed that SWCNH carbon has better catalytic activity. And from board phase flux data is taken from EIS data and calculated the lifetime of charge carriers. And photocurrent density voltage measurements are carried out for the carbon SWCNH carbon counter-electrode based DSSCs, and the photovoltaic parameters are tabulated in this table. The SWCNH carbon counter-electrode based DSSC exhibited efficiency of 11.12%, which is higher compared to the platinum. Based on this highest efficiency, we have fabricated a dye-sensitized solar cell module, which consists of 6 individual DSSCs, which are in series connection together. This bifacial dye-sensitized solar cell module has an advantage to utilize both outdoor and indoor light conditions. By taking an advantage of indoor and outdoor light conditions, the dye-sensitized solar cell module has exhibited a champion intensity of efficiency of 19.71% and a voltage of 3.94 volts. The energy converted in this dye-sensitized solar cell module need to store in one device, that is supercapacitor. Hence, in the same glass substrate of dye-sensitized solar cell module, we have developed a supercapacitor section, and this device is called photocapacitor. The energy converted in the dye-sensitized solar cell module will be stored in the supercapacitor unit, and the energy stored in this supercapacitor is discharged by lighting up an LED. And this is the front view, top view, side view of a dye-sensitized solar cell module, and this is under dark condition while discharging. And CV cyclic voltammetry studies are carried out for the supercapacitor part. A is the CV studies carried out from 10 millivolts per second to 200 millivolts per second under the voltage window of 0 to 1.5 volts. Here CV curves are in quasi-rectangular shape and encircles a larger area, which indicative that superior capacitance. And B is the GCD curves of supercapacitor, which are in triangular shape, carried out from 0.5 milliamps per centimeter square to 1.5 milliamps per centimeter square. And also we have carried out multiple charge discharge curves. And the supercapacitor is constant up to 100 cycles. The D is the graph representing supercapacitor up to 100 cycles. These results are published in KCS Applied Energy Materials Journal. And overall conclusion, graphene oxide and SSR-GO are successfully synthesized and used as platinum-free counter electrodes for high performance dye-sensitized solar cells. By using SSR-GO SWCNH DSSC module, we have operated a tiny electric motor under indoor and outdoor light conditions. In this work, we have developed a flexible TiO2 and electrodeposited MOH2 counter electrode based DSSCs. And in this work we have also developed SWCNH MOH2 bilayer counter electrode based DSSC, which exhibited higher current density and fill factor. And developed SWCNH carbon counter electrode based DSSC, which is exhibiting 11.12% efficiency. And based on this SWCNH carbon, we have fabricated dye-sensitized solar cell module consist of 6 series connected DSSCs and exhibited an efficiency of 19.71% with VOC of 3.94 volts. And also we have developed a photocapacitor. These are the counter electrodes which I have developed during my PhD research work for DSSC applications. No reports are available. Future aspects. No reports are available in development of tandem solar cells consist of perovskite as well as dye-sensitized solar cells. In this view, Intershin developed a cost-effective bifacial tandem perovskite dye-sensitized solar cells. and also have an idea to develop a photocapacitor by integrating the tandem perovskite disintegrate solar cells with lithium polymer based batteries for IoT devices, portable and wearable electronic gadgets, electric vehicles, etc. These are the list of publications related to my thesis work, which I have included in my thesis. These are the list of publications other than thesis work. This is book chapter from PhD research work. This is book chapter other than PhD work. And these are presentations which I have attended or presented. Acknowledgement. My heartfelt thanks to Research Supervisor Dr. M. Raghavendra, Associate Professor, Department of Physics, YVU, for giving me an opportunity to work under his guidance, encouragement, and for his support throughout my study. My sincere thanks to Yogvimana University Authorities, Honorable Vice Chancellor Madam, Registrar and Principal, and Professor K. Krishna Reddy, Sir, Dean Faculty of Sciences, and Professor Y. Najir Ahmad, HOD, Department of Physics, Dr. Y.P. Venkat Subbaiah, BOS Chairman, Department of Physics, and my sincere gratitude to the external examiner, Dr. N.V. Prasad, Associate Professor, Department of Physics, Usmania University, Hyderabad, for sparing the valuable time for this session. And DST Inspire, DST Sir BMR, faculty members of other departments, YVU, research scholars, students of the physics and other departments, and my family members. Response to the suggestions made by subject experts. In chapter 4, reduced graphene oxide and SWCNH SSRG were synthesized and tested as counter-electrode. However, thickness of these films are not mentioned. How the thickness counter-electrode influences the DSSC performance. In chapter 4, we have synthesized reduced graphene oxide, whereas SWCNH was purchased from Carbonium, Italy. The thickness of coated films is about 120 nanometers, which is represented in this figure. And the thickness of counter-electrode influences the DSSC performance. What is the percentage of error in estimating the efficiency of solar cells? The percentage of error in estimating the efficiency of solar cells is about plus or minus 0.10. Honeycomb patterns are seen in the photoelectrode in figure 4.88. Any reason for this? Does it improve the efficiency? In figure 4.88, the TiO2 is coated as graphene-like structure. Only the pattern does not improve the efficiency. What is the reason for enhanced VOC when integrating DSSC with the silicon cells? When two solar cells are connected in series, automatically the VOC will enhance. In the chapter 4, the fabricated disensitive solar cell module is integrated with the silicon. So VOC is enhanced. How was the SWCNH synthesized? Details can be added in chapter 5. Actually, in the present work, SWCNH was purchased from Carbonium, Italy, and is already mentioned in chapter 4. But now the details are included in chapter 5. How did you confirm the nanostructures? The magnification of SEM image shown in figure 5.4 does not show any nano features. Similarly, no discussion on nano size with either XRD or Raman data is given. In figure 5.4 represents the SEM image of MOS2 SWCNH, SWCNH, MOS2 counter-electrodes. And here we have not stated as no statements was made as nanostructures. Presence of MOS2 has the advantage of exposed active edges and hence is considered to be the reason for enhanced electrocatalytic performance. However, how adding SWCNH with MOS2 improves the performance? Is it because of the enhanced surface area rendered by SWCNH or good adhesion to FTO coated substrate? SWCNH contains a higher specific surface area. When it chemical or physical oxidation, the inner tubular area is accessible to extra accessible of reactants. This will enhance the surface active sites and porous nature. The discussion in this direction is already made in chapter 5, introduction part and the results and discussion part. MOS2 based counter-electrode in chapter 5 yielded a current density and efficiency of 18.48 milliamps per centimeter square and 6.27%, where it has 11.56 milliamps per centimeter square and 4.35% for flexible MOS2. What is the reason for the reduction in these values in the case of flexible electrodes? In chapter 5, photoelectrode is made by using FTO coated glass substrate, but in chapter 6, photoelectrodes are made with the ITO coated FTO substrates. A major challenge for making DSSCs on plastic substrate that is flexible is the temperature limitation of the substrate in producing the TiO2 working electrode. What is the advantage or envisaged application of developing submodules of FDSSC? The advantage of flexible DSSCs are already mentioned in the respective chapter 6. Device configuration shown in figure 7.2 is not clear. Why the capacitor top and bottom electrode are in short circuit configuration? Device configuration of figure 7.2 represents the Dyson-ray solar cell is integrated with the supercapacitor. This device is called photocapacitor. Its details are mentioned. The supercapacitor top and bottom electrodes are connected to the external load, which could be discharged under dark condition. The enhanced efficiency in the case of DSSM is due to bifacial illumination or considered counter electrode, that is SWCNH carbon. The enhanced efficiency in the case of developed DSSM is due to bifacial illumination. By bifacial illumination, the DSSM exhibited 19.71%. From one side illumination, the Dyson-ray solar cell module exhibited 11.8% efficiency. These details are mentioned in table 7.3. The SWCNH carbon counterelectrode is also efficient for DSSC and exhibited efficiency of 11.12%. Page number 8. Conditions this makes DSSC suitable. Remove is. In the page number 8, the statement is corrected and removed is. Show the cross-sectional image of DSSC in figure 1.5. The cross-sectional view of DSSC is introduced. Scale bar in figure 4.8, 6.3, 7.1 can be introduced. The scale bar is introduced for the figures 4.8, 6.3 and 7.1. Show the axis and magnification in AFM images. Magnification and axis are shown for figure 6.2. In figure 6.2. Questions to be asked at the time of Viva work examination. Examiner 1. What is the difference between carbon nanotubes and carbon nanohorns? Why did you choose the latter for your studies? SWCNH and SWCNT are differ in terms of their structure. A closure-like structure is appeared for SWCNH and this is more efficient than SWCNT. That's why we have choose SWCNH in the present research work. How do you estimate the electron lifetime from both phase lots? By using the equation tau equal to 1 by 2 pi f. What is the difference between capacitor, photocapacitor and supercapacitor? Capacitor stores the energy in the form of electric field and the energy density is low. And in the case of supercapacitor, the energy density is very high. And a photocapacitor is a device used to harvest and store the energy. Can we use tri-layer counterelectrode for DSSCs? Can you give some examples or suggestions? The reported literature witnessed for tri-layer counterelectrode for DSSC applications. These are some examples for tri-layer counterelectrodes in DSS. Even though DSSCs are cost effective, how are their long-term stability and sustainability for real-time applications? DSSCs are cost effective and it has potentialities like transparency, colorful, flexible and less weight and easily considered to be integrated into portable electronic gadgets, IoT devices and can be installed on the top of windows, walls and roofs of buildings to produce electricity. Furthermore, they have ability to generate power under indoor, outdoor and also diffused illumination conditions also. The literature witnessed that DSSCs have lifetime of up to 10 to 15 years with the solid electrolytes, which reflects its stability performance towards real-time applications. And examiner 2, did the student look at the influence of properties like crystal structure, grain size, defect density, conductivity, etc. of different counterelectrodes on the performance of DSSCs? In the present work, we have not performed these properties for the prepared counterelectrodes. The SWCNH carbon DSSC has shown the highest efficiency than all other DSSCs investigated in this work. Why? The SWCNH carbon counterelectrode DSSC shown highest efficiency because of its higher electrocatalytic performance, Tafel polarization, etc. Thank you.
Hello?
Sir, and Dr. M. Prasad, sir.
Hello, Ajay, yeah, just one minute. Gurulakshmi have done very good work, Amma. Really, it's applied work and you have explained about that. And I think that you have answered all the queries what made by referees excellently about that. I have two questions I want to ask you about that. You have drawn the Kolkol plots. From that, you can calculate the relaxation time. Why you used both plots once again? Gurulakshmi.
Sir, your voice is very low. Could you raise
You
your
have
voice?
calculated the relaxation time from the board plots. You can calculate the relaxation time directly from the spectroscopic plots. Why you made that? Question number one.
Sir, your voice is very low. Could you raise your volume, sir?
Okay, is it okay now? Yeah. Is it okay? Is it okay? No. I've raised it.
Little bit more, sir.
Little bit more.
Okay, sir, right now.
Okay, now?
Yes, sir. Yes.
Now, Gurulakshmi, you have really did a very good work, Amma, and you have really completed work and very applied work, what you have completed about that. And you have referred all, I mean, you have answered all the questions what the, referees have raised it. I have two questions once again for you. It's a very, basic fundamental questions, don't get hesitate. The question is, you have calculated the relaxation time from the board plots, right? You can also calculate, no, one minute. You can also calculate the relaxation time from the directly fitting the spectroscopic plot, that means Kolkol plot. Why you made that?
From board phase plots, I have calculated the lifetime.
Why? What is the reason for that? You can calculate from directly the complex plot, no? Maybe for accuracy. Maybe for accuracy, you have calculated that, right?
Question.
Could you repeat your question, sir?
No, you calculated relaxation time by using board plot.
Board phase plots, yes, sir. Yes.
Board plot. You can calculate same relaxation time by fitting the Kolkol plot. Why you have done that? Is it for accuracy or just like that?
Sir, actually, I have not performed board phase characterization. The data is taken from EIS data. It is an indirect method, sir. From this EIS data, I have taken data and calculated lifetime of charge carriers.
Okay. In both plots, you have got two peaks. Why? Two peaks
Yes,
are showing.
2 peaks. Oh, yes.
Why? What are they? What are they?
Board phase plots, yes.
You are getting two peaks, right? One
Yeah,
peak is very
yes.
high and another is very small like that. So what is the reason for
For
that?
higher peak, I have taken as frequency of, sir.
Then, okay. Okay, then,
And for lower peak,
okay. Lower peak for
actually, the graph actually came
No.
as 2 peaks.
yeah. In order to calculate the charge carrier concentration, other
Yes,
things.
sir. For higher peak, I
Ah,
have taken as
oh.
peak frequency and
Okay,
substituted in the equation.
okay, very good. Then next, how you conclude that carbon electrode only is the best one when compared to the other one? The same, because you have answered the question.
Yes, sir. By considering top fill polarization, EIS, and by considering board phase plots data, and finally, I have considered efficiency, sir. After performing these characterizations, so based on these properties, I have concluded that SWCNH carbon has carbon exhibited highest efficiency.
Yes, the same thing can be concluded by this what you call high peak and low peak. From that also can conclude, because you said that charge carriers are electrons, right? They are
Yes,
reflected based on the characteristic time. So that from that you can calculate it. Very good work, Amma. Really very good work.
Electron lifetime is higher.
Yes, that's the reason you have got. You can corroborate your results in this. Okay, very good work you have done. I request to the BO sir and HOD sir and that's faculty members.
Please, sir.
Kindly, Dean sir. Sir,
What is open for Q&A? So first person we have asked the latest person who entered in the room. Prasad Garu, we have opened for question and answer.
okay, sir.
Sir Krishna Reddy from Department of Physics, presently team faculty assistants.
sir.
So there is no question from material science and nanotechnology. Yesterday we had the rationalization. So they asked the amalgamate the material science nanotechnology with the physics department. I fought and I told very specifically that it is the hybridization of chemistry and physics. And also it has the highest publications and the order of the day is nanotechnology. So that's why the department also. My question is okay. Next mark. Question two. Question please. Veda.
So here the platinum you referred, is it a platinum paste or nanoparticle? Paste, but dispersed in some solvent.
Directly, I have.
Oh,
Directly,
yeah.
Paste, it's a paste,
Raghavendra.
it's a paste, platinum paste. The city measurements you recorded in which exercise?
Yes, yes.
Like that?
No, no.
So what could be your observation? See, the carbon materials is showing considerable current through series, but that's what I have seen. So do you have any specific reason why you observed good amount of current on carbon material? Considerably is good in conductive. Sometimes it is comparable with platinum. So that's what it's very interesting, but have you seen the reason?
The carbon is not clear. So I have used the less quantity. Carbon I have used 3 liters. That is the That's it.
So the area you quoted is the same for
And
test area. What it could area.
shout out.
Performance.
Oh, no.
Carbon material. Good for
Don't be our last one. Sarah?
What is very nice. You have tested the gas plate with the sun area, right? And you have measured. And again, you have screen printed, like inspired that. You have measured the production activity for that area and screen printing.
I have quoted inspired only for supercapacitor. This is not for.
Is it affecting on the surface area also affects that? But when you do the screen printing, that total area is removed, right? Then the area, that's what,
That's right.
because we have calculated the total area. And the screen printing area is, we have to omit, right? Have you done that?
But actually, I have used same active area for dye-sensitive solar cell. And the inspired active area is only for supercapacitor. It is only used for storage purpose. It is not to reflect the impedance. It does not reflect efficiency.
That's not.
Only for supercapacitor. All I have used for global.
Surface area is not affecting.
Surface not. That is not for the dye-sensitive solar cell. It is only for supercapacitor. It is only used for storage of the energy converted in the dye-sensitive.
సో క్వశ్చన్ నువ్వు లేవు కదా సర్లే మా సుబ్బయ్య ఈగర్లీ వెయిటింగ్ మేడ్ సెవరల్ ఆర్ఆర్ఎన్స్ అండ్ ఆఫీసర్ అనుకుంటు చేద్దామా నువ్వు చేసి చూడు క్వశ్చన్ మా హెడ్ ఆఫ్ ది డిపార్ట్మెంట్ అడగచ్చు బాగా క్వశ్చన్
Thank you for the opportunity given to our department, sir. So, you have done excellent work course, I didn't see your slides. I found your publications. I once saw your publication that time. I came to know about your work. It's a good work, publication and good essay journals. That is a normal metal free. Normal metal free metals you are useful for the essential solar cells. What are the details you have taken? Okay, single wall component, horns, component. Can you find any size or morphology size effect in their performance? Size, particle size, or the morphology, did you compare any performance in that? We know that we have very good conductive material. But if you have a good interface, then only the performance can be improved. When you have any evidence about the improved performance of your material with the dial? Well, my question is clear to you. Okay. So how it is superior compared to your own material and the literature? When you compare the literature report saying one material, so how it is superior? Okay, so this method is cost effective and okay, right? No, but efficiency wise, how much percentage? That's 1%. Okay, so do you have the justification why it is increased? It's not just observation, but how it is improved because of the interactions of other what type of interaction. So this can be very helpful for future work. The interface, surface interface engineering is a crucial role for your performance. The material externality or the other characteristics it can be very good. But if we miss that interface, the performance is what I think.
Professor Ramu. అడుగురా రాకపోతే ఎట్లా నిండుగా ఉంటుంది.
Okay. Yeah, I appreciate your publications. Really, and as well as really doing starting on this job. Very happy. And the basic question, the existence for ourselves, it's better to identify the interactions, how the metals interact. The other question is, suppose two ways of work is going on this. Some of the chemistry people are focusing on the synthesis of some molecules and they are using it as the source. The physics people and nano people are totally focusing on the metal combination. So which one, according to literature, which one is showing the better efficiency? Organic molecules or the metal combination? Have you come across?
Platinum is champion counter electrode for DSL. But the metal combinations.
Metal combinations good. With the physics is good.
By selecting the dyes. By selection of dyes.
Yeah, process is also similar. Organic compound by synthesis is a tedious process.
Metal complexes are very stable, but the organic metal complexes are stable.
Yeah, that's why the enormous work is going on. That's the basic doubt. Thank you.
Nice. From scholars, students, if anyone left out from the faculty, if not, so గురు పూర్ణిమ రోజున మన గురులక్ష్మి ఒక మంచి పరిశోధన చేశారు. ఆ పరిశోధనలో కూడా ఆవిడ ప్రచురించిన ప్రతులు, పుస్తకాలు మరియు వారి నాణ్యమైన పరిశోధనలు ఈ మన ముగ్గురు వ్యక్తులు ఎవరైతే శాస్త్రవేత్తలు ఎవరైతే దాన్ని శోధించి దాని లోపల ఉన్న చిన్న చిన్న లోపాలను కూడా చూసి ఆ లోపాలని కూడా వారు ఒక నివేదిక రూపంలో సమర్పించినప్పుడు వాటికి కూడా గురులక్ష్మి బాగా వాటికి రెస్పాన్స్ రాస్తూ వాటిని మొత్తం చూపెట్టినప్పుడు నేను పక్కన ఉన్నమ్మా నా తోటి అధ్యాపకుడితో చెప్పిన, ఎవరికైనా బాగా ఇంట్రెస్ట్ ఉంటే దాని మీద, who is very much interested on a research, definitely he will go through the entire thesis and he is going to see all the aspects couple of times, 3 times, 4 times or n times, and he has given some of the comprehensive and also they are all for the adding to the thesis flavor much more. So really we have to appreciate, congratulate Guru Lakshmi as well as her guide Dr. Raghavendra for taking these DS, the dye synthesized solar cells. So is one of the his bread and butter, and through this our department had a good name, and definitely she will bring good name to the varsity elsewhere if she goes for other research progress, maybe could be as a PDF or something else. So I sincerely wish and congratulate the both guide and student, and we have no hesitation to in concurrence with in concurrence
మళ్ళీ ఫోటో పెట్టు వైవా జరుగుతుంది.
in concurrence with the external examiner, so we can award the PhD degree after completing the Yogyamana University formalities. So this is from my side. Now I request head of the department, Dr. Professor Nazir, followed by Dr. Venkat Subbaya, to say a few words.
Very excellent work. It actually states the publications. The publications, they are very strong, you know. The five factor of the publications are also very, very good. And let me once again congratulate and say all the best for your few weeks. Thank you.
First, I would like to congratulate Adana Gurulakshmi and then for bringing out excellent all the adjudicators. I have gone through the reports, all the adjudicators, they have rated results of the excellent. Once again, congratulations. So she has different counter electrodes, and she has thoroughly characterized all the counter electrodes. She had made small DSSC cells followed by DSSC modules, followed by, she also made an attempt to integrate the DSSC cells with silicon solar cells. And she has also attempted and succeeded in successfully running the tiny motor. So all these devices, so the thing that shows that she has not only characterized the material, and she has completed, I can say that she has made a complete study. And also she has proposed different counter electrodes to the research community, and which has been evident in high-rated publications. And she has also, we have to congratulate, they also published the various it is not easy thing to get ACS. I once again congratulate, I wish her all the best for her postdoc, for future research career.
With the last year, I can manage.
Yes. Sir, NV Prasad, sir.
దీంట్లో ఆఫ్ చేశారు మీరు యూట్యూబ్
Okay.
Sir, can we, in the session, sir?
నాదిరా ఇది పడేయాలి
నాకు
Sir,
అర్థం కాలేదు, అర్థం కాదు.
Sir, could you please make your comments like
One second,
conclude?
once again,
Yes.
No, no, okay, Subbalakshmi has done really, Guru Lakshmi has done really good work and published very good work. And I congratulate both Raghavendra and Guru Lakshmi for nice work. And I wish you all the best for your future endeavors.
Thank you, sir. Thank you. Thank you, sir, for your guidance.
And as a, once again, I'm thankful to the committee giving me an opportunity as examiner and to work with you. Nice work. Hello?
Thank you very much, sir.
Thank you very much. So, shall we leave?
Yes, sir. I will send the formalities like
Okay,
minutes of
okay,
the
okay.
meeting. So,
Okay, can I leave? Can I leave? All
Yes,
the
sir.
best. Raghavendra, all the best and best of luck.
okay, thank you, sir.
Bye.